let's go to page 298. And this lesson is a little bit extra about conjugates and absolute values. So if you let z equal to complex number, so z equal to x plus y I, and when you have the little bar over on top of it, right? This means conjugate. When you have the bar on top, that's a conjugate. So this becomes x minus y I. Okay. So now there are certain theorems. So theorem 1, okay. So 1a, so theorem 1a, when you have a w plus z, conjugate of the whole thing is equal to conjugate of w plus conjugate of z. So now we can kind of distribute and separate. Okay, same thing with the subtraction. So this theorem 1b. So when you have the minus, so when you have w minus z and you take the conjugate of that, this will equal to the conjugate of w minus conjugate of z. So this is good for addition, subtraction, multiplication. Okay. And also for division. So when you have w divided by z and you take the conjugate of that, this will equal to w conjugate divided by z conjugate. And because you have division, so z cannot equal to 0, okay, because it will make undefined. Okay, so another thing you need to learn is that the absolute value of z, okay, is equal to square root of x squared plus y squared. So what it's saying is this. See, when you have an x plus y I, okay, if you sketch that, okay, so it's going to be x, y, so that's your real number, that's your imaginary number, okay. So that's your x, here's your y, and here's your absolute value of z. So what it's saying is that when you sketch it out into a triangle, this would be the absolute value, would be the hypotenuse. Okay, so keep that in mind, that's going to be very important. Okay, so let's go to example 1. Example 1a, if you have z equal to 4 minus 3i, okay, if you use Pythagorean theorem, okay, then you're going to get absolute value of z equal to square root of 4 squared plus, now the I is just a direction, so don't put I in here when you figure it out, okay? So it'd be minus 3 squared, again I is a direction, okay, because this is a real, this is imaginary. So absolute value of z equal to square root of 16 plus 9. So absolute value of z equal to square root of 25. So the absolute value means the length equal to 5. Okay? So this is a long way. But if you know your spatial triangle, then you can just sketch it out. So you got 4 minus 3. So here's your real number, here's your imaginary number. So you go 4 and minus 3. So that's your 3, 4, 5 triangle, right? So right away you can see that this is a 3, 4, 5 triangle. So therefore absolute value of z equal to 5. Again, absolute value means the length, okay, the length of the hypotenuse. So if you know your spatial triangle, you don't have to do all this long way. You can just go 3, 4, 5 spatial triangle, okay? So some of the spatial triangle are like 3, 4, 5, right? And 5. The easy way to remember is that square of this will equal 2 consecutive numbers. So 5, you square it is 25, so it would be 12 and 13, right? Okay. And if it's 7, it's 49, so it would be 24, 25. Okay? So you got to know your spatial triangles. And any multiple that like this, the double that would be 6, 8, 10, right? And this would be 10, 24, 26. Okay. Now the other one that another common one you're going to see is 8, 15, 17. Okay. So this is so you kind of want to recognize this so that way it will save you a lot of time doing this. Okay. So let's go to B, example 1b. You got z equal to negative 6i. Okay. So again, if you sketch it out, So negative 6 is right over here. And what's the length of that? Well, answer is 6, right? So absolute value of that equal to 6. Okay? Because this is negative 6, right? Again, negative give you the direction, but the absolute value means length is always positive. If you do the Pythagorean theorem, you're going to have absolute value of z equal to square root of 0 squared, right? That's your real number plus negative 6 squared. Again, you work it out, you're going to have absolute value of z equal to square root of 0 plus 36. And again, you're going to get absolute value of z equal to 6, right? You're going to get same answer. But again, if you understand what this means, the absolute value means the length of the hypotenuse. You can sketch it out, you can bypass all these. Okay, let's go to C. Actually, we can do a C over here because C is super easy. Okay, so 1C, you're looking for z equal to negative 2. Okay, so this is a real number, so negative 2 is going to be right over here. Okay, so the length of that will equal to 2, right? Again, and it makes sense, right? If you take absolute value of that, you're going to get that, right? Okay, and that's it. Okay, so again, you can use Pythagorean theorem or you can just sketch it out. Okay, now let's go to page 299, and here's a theorem number 2 that the square of the length equal to z times is conjugate. So when you multiply two conjugates together, it will become square of its length. Okay? Again, this is very similar to the Pythagorean theorem. Okay, and then, so if you were to move things around, okay, so 1 over z. So what happens is if you move things around, okay, so let's say if you divide by z, the conjugate of z, so this will cancel out, right? So the equal to that, and if you flip both upside down, then you're going to get 1 over z. I'm switching, so flip it over, you're going to z conjugate of z over the length squared of the length of z. Okay, so these are additional equation that you can use. Okay, so let's go to example 2. It says use the fact that 1 over z equal to z conjugate over absolute value of the square of the absolute value of z. Okay. Okay, so for A, if this is equal to 25, then 1 over z. So this is talking about from example 1. So example 1, the A is z equal to 4 minus 3i. Okay? And we already found that absolute value of z equal to 5, right? From example 1 from here. Okay? And the conjugate will equal to 4 plus 3i. So 1 over z, using this formula, will equal to z conjugate, right? Conjugate of z would be 4 plus 3i over the z square, absolute value of z square would be 25. So 1 over z will equal to 4 over 25 plus 3 over 25i. Okay, and you want to write in the a plus bi form. Okay, so that's example 2a. Now let's go to example 2b. Example 2b, again, the z equal to negative 6i, and conjugate of that equal to 6i, and the z, absolute value of z equal to 6. So absolute value square equal to 36. So 1 over z, okay, and you can check, right? 1 over z, if you know it from here, is 1 over negative 6i, okay? but you can check, right? So if you use the formula, okay, would be the this one over here, 6i divided by square of that over 36. Okay. Okay. Back up. Okay, so z equal to that, and 1 over z equal to 1 over that. And then you have to simplify. You can have I in the bottom, so you have to times by I to the 3. So 1 over z equal to negative I over negative 6. And this way cancel out. So 1 over z will equal to 1/6i. Okay? So you can do it this way, but most of the time, when you have complex number, this is harder to do. This one has only one term, so easy to do. But when you have like a plus bi form, it's going to be hard to do. So that's why you want to do it this method. So again, 1 over z equal to, you cancel out, so it'll be 1/6i. So you can see they are the same answer, right? Okay. But again, this method is much quicker than this method, and that's the reason for using the formula. Okay, so this is example 2b. Okay, let's go to example 2c. So again, this is from example 1. So you got z equal to negative 2. Now in this case, now this is much easier, right? 1 over z will equal to 1 over negative 2. Okay, and that's it. So it kind of depends on the situation. If the z is kind of complicated, then you don't want to do this method. Okay. So the conjugate of that will still equal to negative 2. And so 1 over z equal to negative 2 over, oh, we forgot the absolute value of z equal to 2. So absolute value of z squared equal to 4. Okay, and so this will equal to negative 2 over 4. So 1 over z equal to negative 1 over 2. Again, you get the same answer. Okay, so it depends on the situation. If you have a very simple problem, then direct method is easier. But when you have a complicated, like this one over here, when you have a complicated complex number, then the formula method is quite a little bit quicker. Okay. Okay, let's go to theorem 3. So theorem 3, again, w and z are complex numbers. So when you have the multiplication, so this is talking about the length now. So compared to theorem 1, see the theorem 1 is just talking about the complex numbers. Now it's talk about the absolute value. So absolute value of w times z will equal to absolute value of w times absolute value of z. Okay, and so this is A. B is when you have division. So when you have absolute value of w over z will equal to absolute value of w over absolute value of z. Again, z cannot equal to 0, right? Because it make it undefined. Okay, so for C, talking about the length. Remember, absolute value means length, right? This is going to be equal to less than or equal to length of w plus length of z. So what it's saying is this. When you have a triangle, okay, this is absolute value of w, absolute value of z, and this is absolute value of w plus z. Remember, absolute value means z, means the length, right? So what it's saying is that the hypotenuse has to be less than the two together, okay? Because if this is bigger than these two together, then you will not have a triangle. So the longest this can be is when equal. Okay, the longer this can be is equal. If this is a hypotenuse is longer than these two together, then you will not have a triangle. Okay, so this can be less than the two together, than the sum, or equal, but cannot be bigger. Okay, again, this is called a inequality identities. Okay. Okay.